Hi everyone, thank you for joining us today. Today we are going to focus on probability and counting principle from your November grade 12 2021 past paper. Okay, question 12, 12.1. A and B are independent events. It is further given that probability of A and B is equals to 0.3 and probability of only B is equals to 0.2. 12.1.1, they want us to state whether or not A and B are mutually exclusive, and we have to motivate our answer. Are A and B mutually exclusive? Yes or no? The answer is what? It's no. Why are we saying no? Because probability of A and B is not equals to 0. Remember, with mutually exclusive events, these are events that cannot occur at the same time, right? They cannot occur at the same time, meaning that we expect the probability of the intersection not to be there. If we have to draw it on a Venn diagram, we can deduce that indeed here event A and B are mutually exclusive because probability of A and B is not there, right? So it's not there, meaning that they cannot occur at the same time, meaning they don't have an intersection. That's what we mean by mutually exclusive. All right, let's go to 12.1.2 now. 12.1.2, determine A, probability of only A. Determine the probability of only A. And they've given it 4 marks, right? It's quite an important question, quite tricky a bit. How can we find the probability of only A? So in simple way you can determine this is for you to first sketch your Venn diagram, right? So if we go and sketch the Venn diagram between event A and B, right? So event A and B, right? You are given that probability of A and B is what? Is 0.3, meaning that we are going to put 0.3 at the intersection, right? And we are given that the probability of only B, remember that only B is this portion here, only, right? Is what? We are given it as 0.2, right? Now they want us to get the probability of what? Of only A, right? How can we get probability of only A? Remember, we need to get that one, and also we need to get on the outside if there's anything there. So keyword that we are given here is that event A and B are what? Are independent events. What do we know about independent events? So if 2 events are independent, then we know probability of A and B will actually be the same as probability of A multiplied by probability of B. Take note of that I'm not saying A only and I'm not saying B only. I'm just saying probability of A multiplied by probability of B, right? So meaning it's the whole circle for A is the whole circle for B. We are not saying only, so be very careful with that. Okay, so probability of A and B, we have it, right? So we can just simply write that statement because it's very useful in solving this question. It's equals to probability of A multiplied by probability of B. And why are we writing this? Because we are given that A and B are what? Are independent. So that is the rule, right? We talked about it in one of the probability sessions. I'll just put the link for that session on the description below also. All right, so probability of A and B is what? Is 0.3 is equals to what is probability of A? We don't know it, right? We just know part of A is 0.3, but we don't really know what is the probability of the whole circle of A because we don't have A only. So we'll just keep it as probability of A. What is probability of B? Be very careful not to say 0.2, right? Because this is the probability of only B. But in this case, we are saying probability of what? Of B, meaning that we are going to take everything that lies in the circle of B, which is 0.3 plus 0.2, right? Which will give us what? 0.5. All right, to solve for probability of A, we're going to divide both sides by 0.5, divide by 0.5, this cancel this. Then we'll find that our probability of A is equals to what? Is equals to 0.3 divided by 0.5, which will give us 0.6. Okay, so probability of A is 0.6. Remember, this is not the probability of only A, but it's the probability of A, meaning that is the probability that includes everything that lies in the circle for what? For A, right? So we can write 0.6 is equals to probability of A, but probability of A there is made up of A only, which is that portion, and also intersection, which is A and B, right? So we can replace probability of A by probability of only A plus probability of what? Of A and B. So these two combined, they make probability of what? Of A. Probability of A, it's A only there, and also the intersection between B, A and B, right? So we can just simply replace probability of A and B by what? By 0.3, because we are given initially, and now go and solve for what? For probability of only A. That's why it had 4 marks. Okay. So when you transport 0.3 to the other side, you get that the probability of only A is equals to 0.6 minus 0.3, which will still give us 0.3. All right, let's now move to B. It says determine probability of not A or not B, right? Not A or not B, right? Okay, so by just looking at this, we can quickly remember the addition rule that says that probability of A or B is actually equals to what? Probability of A plus the probability of B, right, minus probability of what? Of A and B. Okay, so from the addition rule, right, we can simply use the addition rule, but I'm just going to show you the other approach. But we can use the addition rule for this. We say probability of not in A, it will be probability of what? Not A plus probability of what? Not B plus, minus, because it's the addition rule. It's a probability of A plus probability of B minus probability of their intersection, not A and not what? Not B. Okay, so how can we solve this now? Let's go and see what is the probability of not A, everything that is not in A. Remember, with our Venn diagram, we were not done, right? So let's just go and add those things. We know that all probabilities must be equal to what? The total probability must be 100%, which is 1, right? So we are going to say 0.3 plus 0.3 plus 0.2. They are giving us 0.8, meaning that the remaining 0.2 must be what? Must be outside. Okay, so what is probability of not A? Probability of not A is the probability of everything that is not found in A, right? So everything that is not found in A, it's those things that is found in B and outside, which is 0.2 plus 0.2, which is what? 0.4. All right, 0.4 plus probability of not B, right? Let's go and check probability of not B, although this is a quite long method, but let's just use it for the sake of understanding. So probability of not in B, it will be the probability of everything that is not found in the circle of B. So it's everything in A only and also outside. 0.3 plus 0.2, which will give us 0.5. Minus, we go to probability of not A and not B, right? The intersection between not A and not B, right? Let me write this. Not A and not B. What is not in A, right? Not in A, we circle this one outside, right? I'm just gonna use another different color for you to be able to understand this. Let's go to not B. Not B is everything outside, right? So we want to know the intersection between not A and not B. It's obviously what? 0.2. Here's where their intersection, red and yellow, right? Only is there. So it's what? It's 0.2. So we'll subtract with 0.2. Then this will be 0.9 minus 0.2, which will give us 0.7 as our answer. Okay, but this was quite a long method using the addition rule. We can just simply use a straightforward method from this. Okay, let me quickly show you. So we need probability of not A or not B, right? So or means union, right? So we are just going to take all probabilities of not A, we add them with all probabilities of not in B, but without actually repeating, right? So that's very important. Not A is going to be what? We are saying not A, so anything that is not in A is 0,2 plus 0,2, which is 0,4, right? Or means we are adding things of not B. Let's go to not B. Not in B is what? Remember, we are adding everything without repeating what we have already added, right? So not in B, I'll use a blue color. Not in B, it's outside here, but we don't have to repeat whatever we have already added. So 0,2 has already been included, so we'll just add with 0,3 because we didn't need to repeat, right? So it will be plus 0,3. So that one gives you a straight answer, which is what? 0,7. All right, that will be the probability. All right, let's go to 12.2. 12.2, a teacher has 5 different poetry books, right? So we have 5 poetry books. I'll just use P. 4 different drama books, 4D, and we have 3 different novels, right? She must arrange these 12 books from left to right on a shelf. 12.2.1, it says, write down the probability that the novel will be the first book placed on the shelf, right? What is the probability that she's going to place the novel first on the shelf? All right, so probability of an event is equals to the number of events or number of favorable outcomes over the total number of what? Of sample space. We want to get the probability of her putting the novel book, so it will be what? It's going to be the number of novel books that are there. It's 3 divided by the total number of sample space, which is 5 plus 4 plus 3, all books, right? So it's 3 out of 12, which will give us 3 divided by 12, it will be 1/4. So this is our probability. Remember, probability, if we're saying for putting a novel, for putting a novel book first, obviously it will be how many number of novel books do we have out of how many in total, the total number of books that we have that are possibly can be placed also. So we say number of novel books over total number of sample space, then we get the answer, right? 12.2.2, calculate the number of different ways. So this is counting principle, right? When you start to hear the number of different ways to arrange items, the number of different ways in which we can select things and all those things, it's counting principle, right? Calculate the number of different ways in which these 12 books can be placed on a shelf if any book can be placed in any position. All right, so the question that you ask yourself answering a fundamental counting principle question is, how many choices do we have of items that need to be arranged, right? So you know that if we want to arrange 5 different items, the number of different arrangement will just be 5 factorial, and you must just not memorize factorial. I know a lot of students just think counting principles is all about factorial, but you can actually not use the factorial notation and just use your understanding in tackling this question, right? We need to arrange from left to right, right? We have 12 books. That is the total number of outcome, meaning we must have 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need 12 spaces, right, on the shelf, right, from left to right. Okay, so in the first position, how many number of choices do we have? And that's a question you ask yourself when answering fundamental counting principle question, the number of choices that we have in a particular situation. So in the first position, how many choices of book do we have? We can either put one of the 3 novels, right? We can put one of the 4 4 drama books. We can put one of the 5 poetry books, right? So in total, how many choices do we have? We have 3 plus 4 plus 5 books to be arranged. In total, there are 12 books. So we can either put one of the 12 books in that position. But in fundamental counting principle, you only include the number of outcome or the number of choices that you have in a particular situation. So in that first position, you actually have 12 choices of books that you can choose from, right? So as you proceed to the next seat, we assume that you have already placed the book there, right? So how many books are left that you can choose from? 11. As we move, we assume that you have already placed 2 books. How many books are left? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, like that. Then the total number of different arrangements that can be made is simply the multiplication of the number of outcome or choices that we have in that event, and this can be denoted as what? As 12 factorial, and we can just simply use a calculator to get the answer. Okay, so it will give us 479001600 ways in which you can arrange those 12 books. Can you see? It's a lot. If you're doing it manually, you won't even finish, right? So counting principle really simplifies this calculation, enabling us to calculate this different number of arrangement of items that can be made. So in simple terms, if you want to arrange n different things, if in order for you to get the number of different arrangements, just simply say n factorial of those things, right? But there are certain restrictions that you can be given, and you need to follow those conditions and stuff, right? But more practice, go and watch our sessions on counting principle. I think we have about 12 or 13 sessions, I think 15. If you just manage to watch all those sessions, I'm sure you'll be able to master counting principle. I know it's quite tricky. I felt the pressure when I was still in grade 12, but just go and master it from our session. I promise you, it's quite an interesting session. All right, let's move to 12.2.3. All right, so it says calculate the probability that a poetry book is placed in the first position. Now they are starting to give you a restriction, right? Calculate the probability that a poetry book is placed in the first position. I think let me use a red color for this. Remember, we have 12 positions, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, space here. Let me choose another side, or rather let me write it 12.2.3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect, right? So they are saying calculate the probability that a poetry book is placed in the first position and the 3 novel books are placed next to each other. They are now giving you restriction, right? You are not just arranging and the books are sitting anywhere, right? They are restriction. And the drama is placed in the last position. Okay, so if the poetry book, you ask yourself, if the poetry book has to be placed in the first position, in the first seat there, right? How many number of choices do you have in that first position? That is, how many number of poetry books should be do you have that you can choose from? That is the question you ask yourself in counting principle. How many choices do I have for this particular situation? So for a poetry book to be in the first position, you ask yourself, how many poetry books choices do I have? You have how many? You have 5 of them, meaning that you put 5 outcomes in that first position. You can put the first one, you can put the second one, you can put the third one, you can put the fourth one, fifth one. So you can arrange them in 5 different ways. Okay, so you have 5 outcomes there. Okay, so they say 3 novel books are placed next to each other. It means in the other 3 space you have 3 novel books next to each other. So we circle it to show it like it's like one thing, right? How many ways can they be arranged? There are 3, right? Obviously, if they are placed next to each other, here we'll have 3 choices, right? Then we have seated 1 book, we are left with 2 choices. We have seated 2 books, we have left with 1 choices, and this can be simply denoted as what? As 3 factorial. Can you see? Okay, let's move. Then they said, and the drama is placed in the last position. So in the last position we have what? we have a drama book, right? But how many choices of drama books do we have, right? We have how many? We have 4 different choices. Okay, so the question that you might be having, what about the remaining space, right? The remaining space, it will be for the remaining books. Remember, these are just the number of choices that we have, right? But how many books have gone so far, right? Let's count. Here only one book will sit, another book will sit here, another will sit here, another will sit here, another one will sit there. So how many books have gone out of 12? 1, 2, 3, 4, 5 books, right? So 5 books out of 12 are gone. So if 5 books are gone, how many books are left for us to arrange? We're only left with how many books? With 7 books. But here is the trick question. We won't simply say, okay, these 7 books will just simply be arranged in 7 factorial, right? We won't say that, right? Why? Because we have these other 3 that are also form part of one thing, right? They're seated next to each other, but they can sit in this position, they can sit in this one, they can sit here, they can sit here, they can sit here, they can sit there, they can sit there, they can sit there. Can you see? It's either these 3, they must be next to each other, but they can sit in those different positions there. So we also include them in counting to say this pair of books must be together. So in total, we have these ones that are together that can sit anywhere, and these 7 books. So we consider this as 1 plus that 1. It will be how many books in total? 8 books. So those are in set, right? That's why we are considering them as 1, because they must be next to each other. So that is the trick part of this question. So the rest of the books will be 8 books that can be arranged in what? In 8 factorial. Okay, so now we have calculated the number of events, which is 5 times 3 factorial times 8 factorial times what? Times 4. All right, so let's calculate what that will be. 5 times 3 factorial times 8 factorial times 4. So it's gonna give us 4838400, right? The total number of sample space, it's how many can you arrange all the 12 of them, right? So it's gonna be what? 12 factorial without any restriction. So this one that has restriction is the number of favorable outcome, right? It's what we want. We want to put the poetry at the first. We want to put the novels. The novels all together, and we want to put the drama books at the last position. So the probability of this, let me answer the question, because the question needs the probability, right? Not just only the number of different ways to arrange. So probability of an event is equals to what? The number of events divided by the number of what? The number of sample space. What is the number of our favorable events? We have calculated it. It was that tricky one, which is 4838400 divided by 12 factorial, right? You can just simply simplify that, and when you simplify that, it will give you 1/99 as the final answer for probability. All right, great solves. I know this has been quite a long lesson. We were focusing on probability and counting principle. All right, so for more lessons on probability, for more lesson on counting principle, I know it can be tricky. Just click on one of these videos appearing on your screen, and you will actually get the full playlist for counting principle and also the full playlist for probability. Otherwise, that's all for me. Thank you very much for joining, and goodbye.